Okay, all good. So give me the question. So I will quickly do this and understand. So you have kx plus 3y is equal to k plus 1. So from here,
It's not showing.
huh?
It's not showing.
So then y is equal to minus k divided by 3 x plus k plus 1 divided by 3. So check my calculation, right? Then the second one, x plus k plus 2y is equal to 2. So from here you get y is equal to minus 1 divided by k plus 2, right? Plus 2 divided by k plus 2, and then is your so that grade 8 math, so you should be able to do it quickly, okay?
So the x needs to be
Yeah.
x.
So infinitely many solutions. So you know infinitely many solutions means you have three categories here. Unique solution, that means unique one intercept. No solution, they are parallel. Unique solutions, they are parallel. Infinitely many solutions means they should be on top of each other. Right? So they should be on top of each other. Infinitely they are cutting each other, right? So here gradients are not equal, intercepts are not equal. Here gradients are equal, intercepts are not equal. Here gradients are equal, intercepts also equal. Right? So what you guys did, you have to see these are the gradients, right? So if you want to have this condition over here, that means M1 and M2 should be the same, as well as C1, C2 should be the same, right? So first of all, you will get, right? So you will get M1 is equal to M2 condition. So if you do that, you get minus k divided by 3 is should be equal to 1 divided by k plus 2. Right? So end of the day, you get a quadratic here. That quadratic would be k squared plus 2k, right? Minus 3 is equal to 0. Am I right? Yeah. So you should get k is equal to minus 1 and 3. Right? Grade 8 factorization. So you can't dance around there, right? Now, the question we have here is this. If you equate these two, because this is our condition we are looking at, we took this one, right? So we obtained k to be minus 1 and 3. But still, we have to check whether k is equal to minus 1 and 3 will satisfy this. Right? We have to see that. So to do that, what you have to do is this. Let k is equal to minus 1. Then you have to sub that value into first equation and the second equation. So what I'm saying, minus 1 divided by 3x plus minus 1 plus 1 divided by 3. So here you get x 1 divided by 3x plus 0. So if you put that into the other equation, minus 1 divided by k is minus 1 now, plus 2, x plus 2 divided by minus 1 plus 2. There you get, what you get there, minus 1 divided by 2x, am I right? Am I right? Plus, something is wrong here.
K is minus
The
2.
k is 1 and negative.
Oh yeah, sorry. Yeah, it's 1 and negative 3. It should be 1 and negative 3 on my paper too. Because if you do quadratic formula, it's it should be
k squared 2a minus 3.
because it's minus 2
Okay, let me see. So
minus
Oh.
2. Yeah,
here, right?
yeah.
It should be 1 and negative 3.
1 and negative 3. Yeah.
So you put plus here, you put plus here, you put plus here, you put plus here. So it should be now 1 divided by 3x plus 2 divided by 3. Here you get minus, right? Minus 1 divided by 3x plus 2 divided by 3, yeah? So that means when k is equal to minus 1, you can see that m's are the same, c's are the same, right? So that means when k is equal to minus 1, both the conditions, k is equal to 1, both the conditions are satisfied. So when k is equal to 3, what will happen? Minus 3x divided by 3 plus minus 3 plus 1 divided by 3. Look at my calculation, guys. Okay. Let's see whether I'm doing any mistake here. Right? So now you can see here, m's are the same, right? See, m's are the same, but these two are different, see? Right, so k is equal to 3, right? So k is equal to 3, this is not going to work then, right? So what we do, when k is equal to 1, only we get infinitely many solutions. Okay. Also, when k is equal to minus 3, what do you get?
No solutions.
Huh? When is equal to k is equal to minus 3, you get no solutions. Why no solutions? Because this system tells you that these two are parallel to each other. Why? Because your y-intercepts are different. Right? So they are parallel, right? So that's it. All good. Then you need to find. Unique solution, right? So unique solution is when k to be any r value except 1 and minus 3. Right. So if k is equal to 1, infinitely many solutions, k is equal to minus 3, those are precise numbers, right? You have no solutions. Any other k value will give you unique solutions. So how do you visualize it? For example, if k is equal to 2, for example, if k is equal to 2, they can be like this. If k is equal to 1, they are like this. If k is equal to 3, they are again like this. If k is equal to 4, again they are like this. Right? So when k is equal to minus 3, those two are like this. So now you have to understand, in this situation and this situation only, you have no solution and infinitely many solutions. Whatever the other k value you choose, k to the k minus 2, whatever, right? There is a one interceptor, right? So how do you visualize? Now this angle is going to be smaller and larger, making having a one solution here, right? So the k value is doing essentially changing the angle, right? So there is a situation that this k value change the angle, and then these two becomes parallel, on top of each other, and that is k is equal to 1. That is what we mathematically captured. And there is another situation where k is equal to minus 3, they are parallel to each other. Right? The rest of the k values will show you one, intercept. Okay, all good. Now, to practice this, I'm going to give you this assignment. I'm going to send it to you, this assignment, this week. So you can see, so here you can see like very basics things, right? This is for the revision purpose, okay? We have already discussed these things. Now you can see question number 10, very similar, exam type of questions, 11 exam type of questions, 12 exam type of question, 13, 14, see? 14 is a multiple choice question. So this question, these kind of questions you get in the multiple choices as well, to do it quickly, right? So I will teach you another technique to do it today, so that you can do it very quickly, right? So that technique is very quick, okay? So try these questions after the today's lesson. So that would be your homework, okay? Also, yeah, okay, so all of these are there. And some of the questions here, I think last 3 or 4, they are actual VCE questions. So that I make sure that your knowledge is up to the mark, okay? All good. Oh, you two are not there?
No. I
Okay.
think Shane will be there.
You are not there too?
In the Google
We'll do it before you leave today.
Yeah.
You
Oh.
go, you are right?
I'm not.
Okay. So we'll do it before you leave.
Yeah.
All good, guys. So last week we discussed about the matrices, right? So look at the beauty. Just listen to this, then we should be fine. So in matrices, so matrices is the plural word, matrix is the singular word, you know that, right? So in matrices we understood that if you have a matrix A, you can write this one as this as well. So this is ABCD, it's a cupboard. What do you storage there? Data, right? So 2 by 2, we call it order of the matrix, right? 2 is the rows and columns. Now the most important thing is determinant of A. Determinant of A, right, is defined by the diagonal terms here, which is A and D, minus the other diagonal, B and C. That is what the determinant, that is a definition. Okay, so we have to understand that definition. All good? Now, this definition is used to find the number of solutions in simultaneous equations. Now let me do that. Okay, here. So I'll do the same question using this technique, so that you will understand what I'm doing here. Now you have kx plus 3y is equal to k plus 1, and x plus k plus 2y is equal to 2. So now you will see these are the coefficients here. These are the coefficients here. Okay. Now in the previous question what we did was here, when you have the question, we subject y so that we can clearly see the gradient and the y-intercept. Okay, but in this business you don't have to do that drama. You know, you can do the straight business. How to do that? You take the coefficients. The coefficient of x would be k and 3 and 1 and k plus 2. You are going to take it. You put that into a matrix. What you are going to get? The coefficients you are going to get. Okay, right? And that matrix would be a 2 by 2 matrix, right? Then you are going to put x and y here. Those are the variables, and that would be 1 by 2. Okay, so what I did, I got these coefficients k, 3, 1, k plus 2, those are coefficients, right? You just write it like that. But to do that, you should have xy form. xy form you should have, right? So if you have xy form, here you have to start from x, y as well. Suppose the question exam is tricky, so you have y x, y x. So you can store y x, y x. In that way, you have to put y x over here. Now here you have a multiplication in between, right? So you have a multiplication in between. So this is a matrix multiplication. So I told you last week, matrix multiplication is a row column multiplication, right? Row column multiplication. So this row is going to be multiplied with this column. This row is going to be multiplied with this column. So we have to make sure that happens, right? So when you do this row column multiplication, k times x is kx, you are recovering it. 3 times y, 3y, you are recovering it. When you are doing this row with this column, 1 times x, 1x, you are recovering it. It's very easy. K plus 2 times y, k plus 2 times y, you are recovering it. Easy peasy. Right? So this is nothing but matrix representation of simultaneous equations. Now what is a matrix? It's just how you store the data. Right? So there are properties, so there is a multiplication here. Now what would be the output here? Output would be k plus 1 and 2 here. And that would be a 2 by 1 matrix, right? Any question here? Any concern? No? All good? Yeah.
How did you get the answer? Could you please explain?
I can't hear you, Ramdi.
Could you please explain how you got the answer? Because I didn't really know.
What answer?
Like k plus 1 and the 2 will equal.
Oh, how do you get this one?
Yeah.
I just copy this. K plus 1 because this you see K3 is there, right? K3, right?
Yeah.
So parallel to that I am going to put K plus 1.
Oh, okay.
1 K plus 2, 1 K plus 2, parallel to that I am going to put 2 here.
Okay.
X, Y, they are variables. When you multiply it, you pretty much you are reproducing it. Okay? It's just observation. Is there any problem here? I did a deliberate mistake here.
Oh. The order, right? Yeah.
You can't do matrix multiplication if there is a condition. What is the condition? The second guy of the first one should be equal to the first guy of the second one. To do matrix multiplication, right? Let me show you. Okay, so we do matrix multiplication here, right? Let me show you that. See? In matrix multiplication, if you want to multiply two matrices, Q and M should be the same. It's a condition. Then P and N would be the order of the resultant matrix. Yeah, so this is last week. So I did that, see? So when I do this, you have to catch me. Yeah, so be keen enough to catch me. So this is not 1 by 2 anyways. This should be 2 by 1, right? Because 2 rows and 1 column, right? So I'm doing something stupid here, right? So this is 2 by 1. That makes sense. So 2 and 2 are the same. So the output would be 2 by 1. Yes, 2 by 1 here. Now, easy. Now what you can do, you can write this one as A if you want. That A means this matrix, 2 by 2 matrix. Then XY, you typically write X, capital X, and that would be 2 by 1. Short way of writing it, right? Equals to this one. You can say, if you want, you can put any number, any letter here, N. So it's 2 by 1, right? So now, since you have this A matrix, you can find the determinant of that matrix, right? Determinant of A. What is the determinant of A then? That would be multiplication of these two minus the multiplication of those two. K times k plus 2 minus 3 times 1, which is k times k plus 2 minus 3, which is going to be k squared plus 2k minus 3. All good? Yeah. So now I'm going to show you the connection here. Now remember this, okay? Remember this and go back to my previous. Look at my shortcut. So I'm doing the same thing without, structuring the equation. See, I got the same quadratic, right? And equal to 0, right? Y equal to 0. That's what we got when we do the matching in the gradients, right? So I got the same math here. Now we'll go to the other part. See, I got the same matching. See, so the same question we are doing in two different ways. End of the day, the answer should be the same, right? So answer should be the same means end of the day there should be some significant mathematical things matching stuff, right? So that is what we are having here. So now what we do, we will put determinant is equal to 0. Determinant of A is equal to 0 if not F. For infinitely many solutions and no solutions. This is what we understand from the matrix part. You get a matrix here, you get the determinant, you equate that to 0, it's a condition. If you equate that to 0, this condition will give you the k values where you have infinitely many solutions and no solutions, right? So now what you do, k squared plus 2k minus 3 is equal to 0. So you get 2k values, k is equal to 1 and minus 3, yeah?
Yeah.
Now these two are going to be valid for many solution, infinitely many solution condition as well as for no solution condition, right? Visualize it logically. Now you got this one. Next thing would be you have to plug this value to the original equation like before. That part you have to do. You put this one original to the original equation and then see whether the gradients and the y-intercepts are matching. So it's basically what I'm saying. You have to redo this thing. Basically what I'm saying, you have to do this. Once you figure out k is equal to minus 1 and k is equal to 3, you have to plug the values and see whether these are equal or not. That pen is there. Okay. So but if the question is complicated, so you can do this in the matrix way. Okay guys. Now we'll do the question here. Okay, go to question number 14. Try to do this question using matrices. Okay, so now here, okay, so you have question number 14, right? So I'm going to put this into the matrix right away. M here, 12 here, 3 here, M here, put that into the matrix. Then XY here, then is equal to 24 and M. Right? So this is my A matrix. So determinant of A, that would be M times M is M squared minus 36. And that should be is equal to 0 for what? First one for infinitely many solutions, second one for no solution. You understand that? Right? So then you get M is equal to plus and minus 6. right? So now we have to understand this m is equal to plus 6 is for this or the other one. M is equal to minus 6 is for this or the other one. We have to understand that, right? To understand that, what we have to do is m is equal to plus 6. Quickly, you have to put these things into the equation, right? So equation is, what is the equation here? Mx plus 12y is equal to 24. The other one is 3x plus my is equal to m, right? So m is equal to 6 here, so 6x plus 12y is equal to 24. Here you get, if you put 6 here, 18x, right? Plus 6y, hold on, what I am doing. So m is equal to minus 6, right? So minus 6 means 3x, 6x, 12, 24, 3x, 6, right? Plus 6y is equal to 6, right? So when you simplify this a little bit, this is going to be 3x plus 6y is equal to 12, right? Yeah. So this is going to be 3x plus 6y is equal to 6, right? Now if you look at these two, you don't have to do the rest of the math because we are in VCE, right? So we don't have to do the rest of the math, but I will do the rest of the math to show you, to convince you. So from here you can find y here, so that would be minus half x plus 2. If you find y here, so that is again minus half x plus 1, right? Yeah. So now can you see the m's are the same, but c's are not the same? Yeah. Okay. Yeah. So what you can conclude from there?
No, as soon as you get that, you just get the answer. That's what I did. Visa, I need to do this. I don't have the book.
Yeah. So what I was saying here, by looking at this here, you can see 12, you can see 6 here, so you don't have to do this drama, because anyway you understand your gradient would be rise over run, right? Grade 2 man. So rise would be y difference, right? So it would be this one divided by this one, right? Can you understand what I'm saying? This one divided by this one. See, they are the same. So that will tell you that your gradients are the same. Yeah. So you have to be smart there. Use your grade 8 knowledge, right? But if you look at this isolated guy, that isolated guy is he's responsible of giving this, right? Right? Isolated guy, that guy is going to give. So if they are different, that means your y-intercepts are different. So you have to judge it like that. Okay? All good, guys. So m is equal to 6 is responsible for what? No solutions. So now m is equal to next one. Next one also you have to check. Minus 6. If it is minus 6, how it looks like? Minus 6x plus 12y is equal to 24. 3x minus 6y is equal to minus 6. Okay. So now if you simplify this a little bit, right? Minus 6, right? Minus 6, okay, fine. So if I divide this by minus 6, okay, let me see. Minus 6. It's grade 2 math, right? So what to do? So we are going to divide this by minus 2, yeah? So it's going to be 3x. Minus 2 means minus 6y. Minus 2 is minus 2, right? So this is going to be 3x minus 6y is equal to minus 6. Am I right? Yeah?
No, because if you rearrange that, that's going to be no solutions. So
Yeah. Huh?
Isn't it meant to be infinite? Oh, no. Sorry.
Yeah?
Yeah.
Right? Correct? Any question in the simplification? No. Huh?
Yeah, that was my fault.
Yeah. So what I'm saying, these two are again different, right? That is the hint. That hint tells you m is equal to minus 6 also no solutions. Right? Is it possible? Is it possible we get two no solution conditions? What do you think? Answer these questions. You need to become the pro, right? Answer this question. Is it possible to have two m values where you get two no solution conditions? You understand my question? Is it possible, or do I do anything wrong? I feel like the math is correct. It's just simple substitutions, right? If the math is correct, we have to understand, okay, there are two conditions where the lines are parallel to each other. Okay, is it possible? Why not? Why not? Look, if you have a Cartesian here, suppose two lines are like this, parallel, right? Suppose this is when m is equal to 6. Same equation can produce two lines this. So what's wrong with that? So what this m value is doing, by keeping them parallel, they can separate. Possible, right? So that is possible. So m is equal to 6 and minus 6 both will give you no solutions, right? Okay, so but the question is what? Question is unique solutions, right? So question is something else, right? So m is r. Oh, what I'm writing. Okay, r. You skip this. Yeah. Fine. Easy, right? So now you understand you have to do all of these things in 30 seconds in the exam, right? Okay, 30 seconds. Last question on this. Question number 16. A is the answer. So how to get it? I'll show you how I did that. Okay. Now you have to put this into matrix, find the determinant, equal to 0, quadratic, solve it, sub in, observe, decide. See the process? Right? There are 4, 5, 6, right? You can do it in 15 seconds. Do you need to do it? If you need 45 minutes, yeah. Now, if you put this into the matrix,
So then you said do 16. You said do 16, so. That's correct.
is that?
Yeah, you said do 16, so.
Question number 16, that is it?
16 is easy. 16 answers easy.
That's actually jokes.
Okay, so we'll do 17 then. Okay. So A, I'll tell you how to do this mental math. Okay. A is going to multiply with A, right? Minus A. So it's going to be minus A squared, right? Minus A squared. Minus 3, so minus 3 times 3 is going to be minus 3, like that, 9. So this should be minus A squared plus 9. Determinant is equal to 0. So A is equal to plus and minus 3. That you can quickly do, right, in your head. Then you take plus 3, right? So you take plus 3. So if you take plus 3, you put 3 here. 3x, you put 3 here. 3x, 8 minus 3 is going to be 5. Can you see? 3x, 3y is equal to 5. 3x, 3y is equal to 5, right? So that means when A is equal to 3, you get no solutions, right? Is that right? If everything is matching, guys, if everything is matching, there are infinitely many solutions because they are on top of each other, right? So this is A is equal to 3 is wrong. A is equal to minus 3. So if you put minus 3 here, you put minus here, you put minus here. So then you can see minus 3, minus 3x, minus 3y. And you put minus 3 here, so this is going to be 11, right? Now you can see 5 and 11 is different. Right? So now you know that helps you to understand the y-intercepts, right? So two different y-intercepts. So A is equal to minus 3 gives you no solution. Is that an answer? B. Okay, so that's all good. Then you go to 16. Right? 16. So how do you do that? Okay, look at this. Okay, we'll understand this one. Hey, m minus 2 multiplied with m minus 3. Right? Grade 8 math. So do that. So if you do that, you get m squared minus 5x plus 6, right? Then you have to minus this one with this one, which is 6. So life is easy. M squared minus 5x is equal to 0, right? Right?
5
Yeah?
5 m.
Sorry?
5 m. 5 m.
5m.
It's 5 m.
M squared minus 5m.
So m is equal to 0 and 5 here, right? Okay. So now put those values there. So m is equal to 0, minus 2, oh, 2 here, 3 here, 0 minus 3, makes sense. Why? Because there is a minus difference, right? Then if you put 0 here, minus 1, okay, so that means m is equal to 0 will give you so if you put 0, right? If you put 0 here, minus 1, but here is 6, right? So no solution. M is equal to 0, no solution. You understand? Now m is equal to 5. Put 5 here. Actually, if you get a question like that, now you have to throw your experience, right? You don't have to check these things. You can just look at this and that. Right? You put 5 here, 6, 5 here, 4. So again, no solution. So m is equal to 0, 5, both will give you no solution, right?
And m is equal to 5 gives you infinite.
Infinite?
Infinite.
Which
yeah.
one?
M is equal to 5 gives you infinite.
Okay, let's see. How come?
2 minus 5 minus 2 is 3. So the first part would be
Hold on,
3.
hold on. M is equal to 5, right? 5 minus 2 is 3.
Yeah.
Here 2.
Yes.
Here 3. Here 2.
Yeah.
Here 2. Here 4, right?
Yeah.
So you have to match the coefficients then, right? So then, okay, let's do it. 3x plus 3y is equal to 6. So 2x plus 2y is equal to 4. So is this the same?
Yeah.
It's the same, right?
Yeah.
Yeah. So this is m is equal to what? 5. So that means this is infinite solutions. So what is the answer question? No solution. For this one, what was the answer?
B.
Okay, all good. Last question, 18. What is the answer to question number 18 now? Simultaneous equations that have unique solutions. Okay. Sorry. This question is very easy. You can do it like in few seconds. Why? Because once the determinant is equal to 0, whatever you get, they are corresponding to no solutions and infinite number of solutions. What they are asking is unique solution. So just skip it and give R, backslash. So now here, if you do that, you get m squared minus 4. Here you get 6, right? So this is going to be minus 4 here, minus 6 minus 10. So am I right? M squared minus 4 minus 6. So minus 10 is equal to 0. So m is equal to plus and minus square root 10. Am I right? So answer is this.
Yeah.
Right? Why? Because this whatever you get here is for infinitely many solutions and or no solution. So the question is asking unique solution. So you don't have to evaluate, just skip that. Right? So that question is so easy. Any questions? This is how you do, okay? So we need to have a little bit of experience. Now you can understand when we do past paper type of questions, right? I'll show you another question. Then we build up our confidence, right? And that helps you to, that's what we need. All good? Oh, what is it? Go ahead. So you put this into the matrix, right? So this is a short answer question. So you have to do the steps right. Okay. Can I, done? So 3 minus k squared, k squared minus 10, 8 here. Write it down carefully. So you have to write all of these things. 2 by 1 should be equal to 5 and 5k. Okay. So then you have to write then for no solution and infinitely many solutions. Okay, many solutions. Determinant of A should be 0. So you have to say this is A. Okay, so you have to write all those things. Then you can say the math part. So it's 8. So 24, right? 24 minus plus k squared minus 10 is equal to 0. Yeah. So you get here k to the power 4, right, minus 10k to the power 2 plus 24 is equal to 0. This is no-cast question in the first paper. In this question, it's 4 marks. I remember this question. 4 marks. Yeah. So this is 2020, 4-mark question. Out of 30, out of 40 in 2020. So that means that's why they are giving you this much of pay. Now how to do that? Exactly. So you have to say let A is equal to k squared. So then you can say k to the power 2 minus 10k plus 24 is equal to 0. So this should be what now? K plus 12, k minus 2.
It's
Okay.
A.
Huh?
It's A squared minus 10A plus 20.
Okay. K1 is equal to minus 12 and 12. Right? So now we know that these from here, see they are asking units, they are smart. They are asking unit solutions.
So 12 times negative 2 is negative 24.
Oh, so what to do then?
It's negative 6 and negative 4.
I'm so happy today. Negative what?
Negative 6 and negative 4.
I feel like I'm getting old. Six and 4, right? So now to find the unique solutions, right? To find the unique solutions. So you don't have to do any calculation, right? So you can say, oh, you have to find k now, right? Oh, so then what is k here?
Plus or minus root 6 and plus or minus 2.
Pain. Lot of pain. These 4 stupid coach are marks, huh? 4 marks, lot of pain. So here you can say k is this, right? So you can say minus 4. Oh, damn. Why am I writing minus 4? Minus square root of 6 minus 2 and square root of 6, right? Yeah. So that is that. Infinitely many solutions. Now the pain starts. Now the pain starts. Right. Infinitely many solutions. Now you have to put these numbers, right? These numbers, there are 4 numbers, right? Individually. So you have to say k is equal to minus square root of 6. What will happen? Okay. Now this is little easy. Why? Because here you have k squared. So you get 3x minus 6y is equal to 5. Here you get, what do you get here? 6 minus 4x, right? Minus 4x, 8y, minus 30? No. Minus
5 root 6 minus 5.
minus 5 root 6.
Oh wait, no, isn't it? I'm putting in minus root 6.
Yeah.
Am I correct?
What, we have minus 6, right? So that's, oh, wait, no.
Doesn't matter.
Yeah.
Right?
Minus 5, okay.
Am I right or wrong?
Yeah.
Yeah.
Should be.
Okay. So, but there is no matching here? There is matching, right?
Yeah. So
Look.
it's the gradient.
If you look at this, 3 and minus 6 and minus 4 and 8, if you look at m, right? So m is going to be
Minus 2.
half.
Wait, yeah. Half.
M is half, right? What about m here? Half. What about the y-intercept?
Different.
Different. So that means m is k is equal to minus square root 6 is
No solutions.
no solutions, right? This is for no solution. So we conclude that no solution. So likewise, you have to do the next one. Plus 6. Now tell me plus 6.
3x.
Huh?
3x.
Yeah.
Should be minus.
Okay, do it, okay? I can't stand up.
I don't want to eat.
So do it in your book. 3x minus 6y is equal to 5. The other one would be minus 4x plus 8y is equal to 5 square root 6, right? So again the same problem, no solution. Right?
Oh wait, because it's. Oh no.
Again no solution. Now you have to put k is equal to plus 2.
Because it's minus and plus.
K is equal to plus 2. When you put plus 2 here, 3x here, minus 4y is equal to 5. The other one would be plus 2, right? So it's 4 minus 6x plus 8y is equal to plus 2, right? 10.
When you put these to the other side,
Yeah.
What do you think?
Infinitely many solutions.
Sure?
Oh wait, no, that's 6. So,
We put plus 2, right? So plus 2 here,
uh,
plus 2. So here again no solution.
no, so, yeah.
Again this one no solution. Right? So now minus k is equal to minus square root 2. So minus square root 2, give me this.
What? So isn't it just minus 2? It's minus 2, not root 2.
Minus 10, right?
Yeah.
Now that satisfies. That has infinitely many solutions. Right? So infinitely many solutions you get when k is equal to, so this one you get when k is equal to negative square root 2. You get this one when k is equal to why square root negative 2. Okay, positive 2, negative square root of 6, positive square root of 6. That's the answer. So this is the answer to this one. This is the answer to this one. All good? So algebra, so you have to do carefully, but you can see it's pretty easy, right? Straightforward. Okay, guys. So don't lose that knowledge. Okay. Okay. Any questions from there? No questions. Okay. This lesson is very important. Don't lose this. There is no algebra here. No hard math. Right? No hard math. But you have to use this. Right? Think a little bit. Visualize it. Everything will be taught here. But you have to use this, right? Okay, look. The lesson is transformation. Okay, right. So this transformation is not like black Michael Jackson becomes white Michael Jackson. It's a transformation, yeah? Right? So this transformation is not like that transformation. So we have to be precise on what transformation we are talking about. We are talking about coordinate transformation. Right? Now, if you think about the coordinate transformation, what do you mean by coordinate transformation? What do you mean by coordinate transformation? You know coordinate? You know coordinate, right? Okay, think about this is your coordinate. This is XY coordinate. This is before. Right? I'm going to transform this coordinate. How? What do you mean by transform a coordinate? I'm moving it. Otherwise, what to do with this point? Is there any practical thing that you can do with this point? No, you are moving that point. So, suppose you are going to move that point to here. And that location is X prime and Y prime. Different location, right? Different location. So, this is after. Right? It's like I was in US 7-8 years ago. I transformed to Australia. I changed the location. Transformed is like that. That means you are moving from here to here. Right? Now, when you are moving from US to here, Australia, can you just magically, okay, I need to be God, I need to be Australia. Oh, I'm in Australia. Can you do that like that? No. There should be a way to go there, right? So, what is that way? Plane. You catch a plane, you go to Australia. Similarly, here, you need a plane. So that this coordinate is transformed into this point. Right? That plane is we call it in math, right? It's a machine, right? Yeah, airplane, the flight is a machine, right? Aeroplane is a machine, right? So it's a machine. We call it operator. So if you remember, when you are doing year 10-9 math, we understood functions. Function has independent variable, dependent variable. Function is a machine. You give an input, you get the output. You understand those things? Did you know that? Right? Yeah. So it's like a barbecue machine. You put the chicken in, you get the barbecue out. Right? So it's operator. We call it function operator. Now this operator we will discuss later. What kind of a operator you are going to use to have a coordinate transformation. Right? Understand the logic. So then it's very easy. These examples I am bringing in, you might feel stupid examples, yeah, but stupid but very important in the exam. Then when you have a question, you know, oh, I need a operator there. That will come quickly to your mind if you know this stupid example. Okay, so that's why it's important. Now you do the coordinate transformation. So that means XY coordinate is transformed into X prime, Y prime. What is involving? Transformation operator we call it. Transformation operator is what we need. Now, if you want to be here from US, now you can have a direct flight from Dallas to Melbourne. There is a direct flight, or you can touch London and be here. Or you can touch Dubai and come here. Or you can touch Japan and come here. There are so many ways, right? So likewise, in coordinate transformation, there are few ways, right? So there are few ways, types of transformations. First one, what is the first one? You go to Japan and come here. The first one is called dilation. Okay. Second one, you go to Dubai and come here. That method is called X translation. Translation, okay? Not transformation. Translation. This word is translation. Third one, you go to London and come here. Y translation. ABCD. Last one, which is very important. The last one is the one which is coming in the exam. Combination of all three. What do you mean by that? So that means you go to London and London to Dubai and Dubai to here. So combination of everything. So the most important thing would be the last one. There are multiple choice questions as well as short answer. Okie dokie? Right. Okay. Now, I'm going to start X translation here. First. Because it is easy. Also, you have done these things in grade 9 and 10. You know that y is equal to x squared. Okay, listen to this. X translation, you know. Y is equal to x squared. And you know y is equal to x minus 1 squared. Also, you know y is equal to x plus 1 squared. Year 9, 10. If you plot it, this would be like this. This would be like this. This would be like this. Year 9, 10. Right? So now do you know what has happened here? So now can you see that this one became like this because of this is the original one, right? Original one is moved here and this is x direction. Original one is this, it got moved here, that becomes this. Can you see that? Right? And that is X translation. Moving the whole function to right. See, moving the whole function to right or left. Right? Can be seen here, and that is happening in the X direction. See, moving to X, moving away, moving in the negative direction. That, right? Any question? No. Now, but we have to be conscious enough to understand this. What did I say? If you read what I said properly, I said this curve moved to right, and I said it's X translation. That is what I said, right? Okay. But when I was starting the lesson, I said this is a coordinate transformation. Coordinates are moving. That's what I said, right? But when I am here, I am changing my mind now. I am saying curve is curve is moving. You understand what I am saying? Earlier it was a coordinate transform, which there is a coordinate, I am going to transform that coordinate. But here I am saying curve is transformed. There is a contradiction, right? Isn't it? Right? Now how to answer that question? Indeed, this is a function transformation, right? This function got transformed in x direction that everybody can see. but the lesson is coordinate transformation. So how do you understand? It's very easy. What is this curve? This curve is bunch of points, right? This curve is bunch of points, right? So if you think about one curve, one point, if you think about this point here, that point got transformed, translated in x direction. Also the other one got translated, other one got translated, other one got translated, other one translated, translated and became like this. Right? Essentially, this is coordinate translation in x direction, but it appears as a function translation. You understand what I'm saying? So you are the person who came from US to here individually, but in the plane there are so many people, so many coordinates. They came with you. Right? Okay. Okay. So any questions here? No. So you know from grade 8-9 knowledge that if you have this kind of a system, right? So this is x translation in positive x direction, right? So this is translated by 1 in positive x direction. That's how you write. You got what I'm saying? This one we call it translated. You have to use this word translated, okay? Translated. In the exam you have to use it because in the exam you need to do it. Translated by 1 in the negative x direction. By 1 negative x direction. All good, guys? So similarly I'm going to finish the y translation as well. So y translation, so you have this, you have this, you have this. Okay, so you will see that y is equal to x square is like this, but y is equal to x square plus 1, it would be like this. 1 is here. Y is equal to x squared minus 1, it looks like this. Minus 1 here. Right? So how do you visualize it? This is function transformation, but again you have to think function is nothing but lot of points, lot of coordinates. So individual point got translated in y direction, right? So this is the point you are going to consider. That point translated up by 1 in y direction. This point, the original point, got translated down by 1 in this case. Okay, so this is nothing but translated by 1 in positive y direction. This is translated by 1 in the negative y direction. So what is important? Positive, negative is important, translated is important, and direction also important. Okay, all good? Okay, so in the next lesson what we have to do is dilation. I'm going to finish dilation in the next lesson. Dilation is a little tricky when it comes to writing. Concept is very easy. I'll show you how to write it properly, and then combination we'll discuss, right? And hopefully we can do more about this lesson next week. And for this lesson you need to have matrices. That part I'm going to discuss. Okay, so brush up your matrices lesson and then do what we have discussed today again and again. If you have any questions, right? So make sure that you fix it. Okay, guys? Otherwise, it's a problem to you, it's a problem to me, because you are my kid. So if you have a problem, it's a problem to me as well. Right? So please do it.